Look at our next problem. A sample of a compound that contains only carbon, hydrogen, and nitrogen was burned in oxygen. 7.922 grams of CO2, 4.325 grams of H2O, and 0.840 grams of N2 were obtained. How many moles of carbon, hydrogen, and nitrogen atoms? What is the empirical formula, and what is the amount of the mass burned? So, this is a nice little problem. The first thing that we need to be able to do is kind of like diagram what's going on. Um, we have a compound that contains carbon. We have a compound that contains carbon, hydrogen, and nitrogen. It's burned in oxygen to give us carbon dioxide plus H2O plus nitrogen gas. We're told that we obtained CO2 in 7.922 grams. We obtained water in 4.325 grams. And we obtained nitrogen at 0.840 grams. Now the total of this here is equal to 13.087 grams. So 7.922 plus 4.325 plus 0.840 gives us a total weight on the product side of 13.87 grams, which means that this side here, the reactant side, has to also have a total of 13.087 grams. But we don't know that information. We don't know how much oxygen was used, and we don't know how much of this particular sample we had. So we can easily find this out by knowing the information that was given on the product side. We can find the number of grams or moles for each of the substances that we were given. So let's first find the number of grams of each substance. So how many grams of carbon? How many grams of carbon is equal to, we're told that we had 7.922 grams of CO2, and in CO2 we have a ratio. We know that for every 12.01 grams of carbon we are going to have 43.99 grams of CO2. Grams of CO2 cancel out, and our answer is given to us in carbon. So we have 2.163 grams of carbon. Okay, essentially what I'm doing here is I'm saying that one carbon atom is equal to 12, and one oxygen atom is equal to roughly 16. I'm adding the molecular weight up of carbon and oxygen to give me the molecular weight of 44, and I know that one carbon atom is equal to 12. So for every in one molecule of CO2, in one molecule of CO2, I have one carbon atom and I have two oxygen atoms. So that's the ratio that I'm using. Instead of using atoms and oxygen like moles, I'm using the molecular weight. So for every one CO2 molecule, I have 12 grams of carbon, and for every one molecule of CO2, I have um, 32 oxygen atoms. So I'm using that ratio in order to get how much carbon I would have in the problem. So if I look at the next one, if I want to know how much oxygen I have, well, how many grams of oxygen is equal to 7.922 grams of CO2. And from the formula again, I know that for every one um, molecule of CO2, I have 31.98 grams of O2 for every 43.99 grams of CO2. CO2 cancel out, and my answer is going to be given in the grams of oxygen that I have, which is going to be 5.759 grams of oxygen. So that's just for the CO2. Now I can do the same thing for hydrogen or for water using the hydrogen and the oxygen. So I'll ask myself, how many grams of oxygen is equal to 4.325 grams of H2O, and I know in one molecule of H2O I have 15.99 grams of oxygen, and the total molecular weight of H2O is 18.01 grams of H2O. This is oxygen. So when I do the math here, I would get 3.840 grams of O2, which is very, very good because from here I know how much oxygen I had to have consumed of here, because nitrogen, there's no oxygen in it. Only the carbon dioxide and the H2O have oxygen in it. So if I add these two numbers together, which is log conservation of mass, that means this has to be the amount of oxygen that was used. So if I add 5.759 grams of O2 plus 3.840 grams of O2, this would give me a number of, that would be 9.599 grams of O2. This would have to have been the amount of oxygen that was used in order to produce these amounts of oxygens from the carbon dioxide and the H2O. Now, if I know the amount of oxygen here, then I know that the total weight, the total mass for the reactant side has to be equal to the total mass of the reactant side, of the product side. I know that the total mass of the reactant side has to be equal to the total weight of the reactant side. Yeah. I know that the total mass of the reactant side has to be equal to the total mass of the product side. Knowing that information, I can simply subtract 13.087 grams minus 9.599 grams, and that will give me the amount of the substance carbon, hydrogen, and nitrogen. So I'm subtracting 13.087 grams from 9.5922 grams. That would give me an answer of 3.488 grams. So this is how much my substance is, which this here answers part C of your question. Let's continue. Um, let's look at how many grams of hydrogen is equal to 4.325 grams of H2O. And we know that for every 2.016 grams of hydrogen, we have 18.01 grams of H2O. Grams of H2O cancel out, and this would give us a total of 0.4841 grams of hydrogen. And we already know the grams of nitrogen is going to be equal to 0.840 grams of nitrogen, because that's what we were told already. So having done that, what we can now do is we can find out how many moles of each of the substances that we have, because we know the number of grams. So the number of grams of carbon, we're told that we have 2.163 grams of carbon. And we know that if we take our carbon and divide by 12.01 grams, that equals 1 mole of carbon. That will give us 0.1800 moles of carbon. If we ask ourselves how many moles of hydrogen we have, well, we're told that we have 0.4841 grams of hydrogen, and we know that for every 1 mole of hydrogen we have 1.008 grams of hydrogen. Grams of hydrogen cancels out. This gives us our moles, which would be 0.4803 moles of hydrogen. And for our moles of nitrogen, how many moles of nitrogen would be equal to, we know that we have 0.840 grams of nitrogen, and we know that for every 1 mole of nitrogen we have 14 grams of nitrogen, so it's just 1 mole. And this would be equal to 0.06 moles of nitrogen. So now that we know that, what we can do now, we have our carbon, which gives us 0.18 moles. We have our hydrogen, which gives us 0.4803 moles, and we have our nitrogen, which gives us 0.06 moles. Divide by the smallest number of moles. This gives us carbon 3, hydrogen 8, nitrogen 1. So this here is our molecular formula for the compound. Okay, I think we answered all the questions. We know what the mass was, we know the moles of each of the substances, and we know the empirical formula. Alright, that's a wrap.